The most interesting part of Mark Idacola's job isn't watching paint dry, it's watching it move. For Mark, a materials scientist at the National Institute of Standards and Technology, watching paint move is how he's helping improve the safety of the nation's bridges and other steel structures. Mark is on a team that's using speckles painted on bridge components to study how the metal behaves under stress and strain. The work builds on a joint effort between the Federal Highway Administration and the American Association of State Highway and Transportation Officials to better understand how such behavior can lead to disaster. That's what happened on August 1st, 2007, when the Interstate 35 West Bridge in Minneapolis collapsed in the middle of the evening rush hour. According to the National Transportation Safety Board, a design flaw in a metal connector called a gusset plate was the cause. 13 people died and 45 were injured when the bridge's main span plunged into the Mississippi River.
It was decided that it was necessary to look into how gusset plates perform, not only under their expected load conditions, but also in an extreme case where we're going beyond what it was actually designed for.
So the FHWA and AASHTO decided to scientifically determine what it takes to make a gusset plate go bad. Thanks to these massive hydraulic jacks at the FHWA test facility in McLean, Virginia, the easy part is applying the force. What's difficult is measuring the effect of that force. To do that, the Federal Highway Administration uses not one, but 3 different systems to get the complete picture of what stress does to a gusset plate.
We're conducting this series of experiments to help us better understand how gusset plates would fail. And the ultimate goal would be to derive equations which could predict that behaviors.
However, the devices are only sensitive to very small strains in the metal. What they don't do well is measure the more dramatic strains that lead to metal weakness and failure. That's where NIST stepped in to help with a technique called digital image correlation. Like a pair of superhuman eyes, 2 high-resolution cameras in stereo record the speckled pattern painted on the gusset plate. Combined with special software, the cameras track in 3 dimensions the incredibly subtle movements of the speckles over time as stress is applied.
We immediately start getting data, and that data will be able to continuously measure all the way until the failure of the plate, either through buckling or some other mechanism.
The researchers hope their efforts will help the Federal Highway Administration improve the national guidelines for designing and inspecting bridges, so that tragedies like the one in Minnesota will never happen again.